Okay. Okay, so I think we're good. So we're going to be doing some math stuff today, and this is normally in the no calculator part. So let's take a look. So rational expressions, rationals are just when you have a numerator and a denominator. And sometimes when you have certain rational expressions with like an expression in the denominator, you might want to simplify it. They might ask you to simplify it or synthetically divide it or long division divide it, which we won't get into that so much today, as opposed to getting into like more of like the rules and stuff before we do the synthetic and long division. Molly, did you do the synthetic or long division yet or not yet?
No, we're just doing like regular factoring, like just here, let me hold it up, like stuff like that.
Oh, okay.
Yeah.
Okay, gotcha. Cool. Yeah, so and factoring helps with these as well. So that's good that you guys have already reviewed factoring in your class. So when you have a rational fractional expression with a monomial on the denominator, you will need to remember your exponent rules. So monomial is just a fancy way of saying like one term. And terms are separated by addition and subtraction signs. So for our exponent rules, these are something that we have to go over because they could be as basic as just using your exponent rules, or we may have to do some additional factoring and stuff like that in order to simplify, especially when you have like a binomial in the denominator. But just going over our exponent rules, when you multiply same bases, you keep the base and you add the exponents. And then you multiply the coefficients. So an example of that would be like 4x to the 5th times negative 5x squared. Okay, so how I do this is I kind of separate like the coefficients and the bases. So I put them in like two separate parentheses. So I would do like 4 times negative 5 and x the 5th times x squared. And then you're with this, it makes it easier to see what you're doing with the coefficients, especially in front. So 4 times negative 5 is negative 20. And then, sorry, I'm just gonna move this so I can write more. And then x the 5th times x squared, they're the same base. So you keep the base and you add the exponents. Okay. Okay, let's look at this next one. Dividing same bases. So again, you're going to keep the base. Okay, so the base does not just go away if you're dividing or, you know, with any of these. The base doesn't just go away. You're going to keep the base, but when you're dividing same bases, you subtract exponents. And with this, because you're dividing the bases, that means you're also dividing the coefficients. So you're going to divide coefficients. Hey, Ryan, we're just in the notes and we're just going through the exponent rules. So take a look at something like this. If I had 9x squared over 3x to the 7th, I'll even do a negative 3x to the 7th. Let's do that. What you can do with these is you can put like parentheses around the ones that are alike so that you can see the separation. So 9 divided by negative 3 is negative 3. And x squared divided by x to the 7th is x to the negative 5th. Okay. So with this is kind of a review of negative exponents. Does anybody know what a negative exponent does? Or what it means? Okay, so if you have a negative exponent, it just means that to make it positive, you have to change its location. So how I think about this, even though this is not like my life motto or anything like that, but like negative usually means bad, right? So in order to make this exponent good, you got to send it to the basement. But I don't do that. Like, I don't believe in that in all aspects of life. I'm just saying that that's how I think of it. I have to have a story for everything. Okay, so the negative 3 doesn't have an exponent, so you just keep that there. But the x to negative 5, if you wanted it to be good or positive, you send it down to the basement, okay, or the denominator, and it becomes a positive x to the 5th. Okay, so you might see an answer that looks like this, or you could see an answer that looks like this. Either one is correct. The last one is power to power. So again, you keep the base, but you multiply the exponents. And then the coefficient. So as you can see, like for this first one, like we're multiplying same basis, so we multiply the coefficients. We divide same basis, so we divide the coefficients. So the x or the coefficients don't really get like the tricks. It goes by like what the operation is. So if you're raising the entire thing to the power, then the coefficients are raised to that power also. Okay, so as an example, let's say I had negative 2 x to the 7th, y to the 3rd, and we want that squared. Okay, those are powers to a power, and it's separated by a parentheses. So how you can look at it is that all of these separate components of this term, all of these get a power. So you do negative 2 squared, which is 4, x to the 7th squared, which is x to the 14, and y to the 3rd squared is y to the 6th. So basically, like, because it's separated by a parentheses, I just kind of like distribute it to all of them. Okay, even the number in front. Okay, so remember, these are only with monomials, meaning one term, so you don't see any adding or subtracting in them. Okay, now, let's say we have a binomial as the denominator. So whenever you have a polynomial, meaning more than one term, as the denominator of your rational expression, you will need to factor as much as you can in order to simplify. So this is really important here. For this, you need to have the entire expression in order to cancel out. So what I mean by that is, like, let's say I had x and then x plus 3. That's as simplified as you can get it. You can't go through and like cancel the x's out. Okay, that doesn't work like that. This is as simplified as you can get it. Okay. So keep that in mind. But if you had like 2 times x plus 3 over x plus 3, then you could go and cancel out the x plus 3s. And then you'd be left with 2. That would be the simplest. Okay, but you have to have the entire expression in order to cancel it out. So let's look at a few of these, and then I'm going to have you guys try a couple on your own. I'm just looking to see which ones I want you to try on your own. Oh, give me 1 second. It's saying that I have too many applications open. I've never seen that before, so that's interesting. Let's see. Yeah. Hopefully that takes care of it. Never seen that before. Okay. Anyway, so let's look at these. So I'm going to do the first one. You guys are going to do the second one. So looking at the first one, the bottom is a binomial, and there's no exponents or anything like that. So that's as simplified as you can get it. The top one, we can factor it because we want a double bubble that adds to 2 and multiplies to -8. So keep your X's. And if you're having trouble with factoring, what I do is I usually set up like a table and go through, I call it AM because it's add multiply. So I go through the factors of -8 first. So like 1 and -8, those multiply to give you -8, -1 and 8, 2 and -4, or -2 and +4. Okay. And then from there, you see which ones add to 2. And the only one that does that is that last one there, -2 + 4. Okay, so it's going to be x minus 2, x plus 4, all over x minus 2. Now, I have an expression in the bottom that's x minus 2, and I have an expression in the top that's x minus 2. So I can cancel those out, and to simplify that expression, you just get x plus 4. That's it. Okay, so why don't you try number 2 and then just put it in the chat of what you would get if it was simplified. Okay, so for any, like, whether it's Common Core or the SAT, they really like having you factor something with like a 5 and a 6 in it, because that one seems to be the one that people get stuck on the most. So just to kind of show you, we want it to add to -5 and multiply to a +6. So a lot of people are like, ooh, -5. Well, -6 plus 1 gives you a -5. But multiplying those gives you a -6, not a +6. So if you go through, make sure that you, oops, I didn't mean to do that. Make sure that you look at what you have to multiply by. So multiplying to a positive, meaning both signs are the same. So it would have to be like a -1 and a -6, +1 or +6, -2, -3, or +2, +3. So the only one that gives you a -5 when you add them together is this guy. So it's x minus 2, x minus 3, all over x minus 3. These guys cancel and you just end up with x minus 2. Okay, so if you can, try to factor the top first to see if you can get a common factor out. So numbers 3 and 4, I'm going to save for you guys for homework, but number 5, we're going to do together. So number 5 brings in some multiplication here. Okay, which all you have to do is just factor your tushies off, okay, on the top, bottom, left, right, whatever. Okay, factor, factor, factor as much as you can. And then you'll see what happens after that. So this one, we're going to add, multiply. Actually, how about this? I'm going to do the top left one. Molly, you can factor this guy. Abby, you can factor this one. And Ryan, you factor this one. Okay, and just send it to me in the chat. Okay, so just factor the ones that I told you to factor. I'm going to factor the top one, top left. Okay, so we have each of these expressions factored. So this top left one that I did, add to -9, multiply to -10. The only way you could do that is with a -10 and a +1. The bottom left, it adds to a +1 and multiplies to a -6. So that would be +3 minus 2. And then the other two on the right-hand side, those are called the difference of two squares, which it's still going to be a double bubble, even though there's only two terms. But you basically just take the square root of the first, the square root of the second. So square root of x squared is x. And then the square root of 4 is 2. And then one's going to be a positive and one's going to be a negative. Okay. Now, from here, any expression that you see on the top, you can cancel with any expression that you see on the bottom because it's being multiplied. So like, look at this. I'm looking at x minus 10. I don't see that anywhere else on the bottom, so we're going to keep that. The next term that I'm seeing here is an x plus 1, and that cancels with the other x plus 1 on the bottom. And then looking at the next fraction. So I kind of just go like by the numerators and I see if I can cancel any of the denominators. That's kind of a nice way to do it. Some people just kind of like just start canceling out whatever they see. I like to have like some sort of system with it. So x plus 2, there's nothing on the bottom, but there is an x minus 2 on the bottom. And then because it's multiplied, you just keep the ones that are on the top and you multiply them on the top like this. And then same with on the bottom, you keep those ones on the bottom. Okay, so it could look like that, or they could have FOILed or multiplied them out, and they could have gotten x squared, let's see, plus minus 8x minus 20 all over x squared plus 2x minus 3. Okay, either of those could have been an answer, because remember, this is going to be multiple choice. So either one of those would have been an answer. Cool. So I'm glad that you guys are factoring so much at school, because you're definitely going to be needing it for the SAT. So let's look at adding and subtracting rationals. So if you think about adding and subtracting just fractions, so if I had like 1/2 plus 2/3, I don't just get 3/5, right? That's not what happens. I don't just add the numerators and add the denominators. That's not how it works. So when we are adding fractions, we need to find a common what?
Denominator.
Yeah. So look at, like in this instance that I have, when in doubt, just multiply them by each other. Okay, so like this bottom is 2, the other bottom is 3. So I'm just going to multiply both the top and bottom by 3. This bottom is 3, that bottom was 2. So multiply, multiply. So I would get 3/6 plus 4/6. You keep the denominator because we needed a common denominator, and you add the numerators. Same thing goes for any other thing that's a fraction. Okay, we don't just ditch it because it looks different. Okay, if it's a fraction, you're adding or subtracting them, you need to have a common denominator. So with rational expressions, it can get a little dicey because now we're like putting letters and stuff and adding and subtracting. So this is how I do these. So step 1, factor completely each and every expression. So generally what I do is I only factor the denominators. So factor only denominators completely. Okay, the numerators don't really matter right now because we're more focused on the denominators. Once you factor them, you want to find a common denominator. So you're going to list the denominators in factored form and only have one of each factor to get the least common denominator. Make sure all denominators will now have the least common denominators. So just like how we did over here, we multiplied, like we saw that the common denominator was 6. So we multiplied the top and bottom by the same number. We're going to do the same thing for that. Once you do that, you expand it. So you're going to distribute, FOIL, whatever the case may be, and then you simplify. Now, the most important thing here, I think, is don't simplify until the last step. So I don't know how many times that I see students that they factor, and they factor the top and bottom. I think that's where things kind of get a little weird, is when they factor the top and bottom, because then all of a sudden they start like canceling and or they might like find the least common denominator and multiply the top and bottom, and then they start to cancel right away. So don't get cancel happy on me. Definitely do these steps in this order, and don't simplify, meaning canceling out, until the very end. Okay, so I'm just going to show you guys a couple of examples. This is so weird. Can you guys hear me okay? Okay, this thing keeps popping up saying that I have low system availability. I don't know what they're talking about because it's not like I have a lot of applications up. I have the Zoom link and Microsoft Word. So that's fun. Okay, anyways, it's just my computer being goofy. So let's look at number one. So number one, we don't really have to factor anything, right? The bottoms are already in, they're just binomials, so we don't have to do anything with them. And they already are common factor, or they're already same denominators, common denominators. So all you do is you keep the denominator and you combine the numerators. Now, notice when there's a subtraction sign, you want to put that next expression in parentheses. Okay, because you are subtracting the entire expression. From here, I distribute the negative. So I get 4x minus 1 minus 2x plus 9 all over x plus 4. Okay, so I condense, distribute. Now I'm going to start canceling if I can, combining my like terms. So 4x minus 2x is 2x. Negative 1 plus 9 is positive 8 over x plus 4. Now, at this step, we can see if we can try to simplify it anymore to make sure that your final answer is in simplest form. So the bottom, like we said, we can't factor anything, but the top is actually a greatest common factor. We can factor out a 2. So I get 2 parentheses x plus 4 all over x plus 4, and you can then cancel out the x plus 4s, and your final answer would just be 2. Okay, we're doing baby steps here. So looking at number 2. Okay, so again, baby steps. So that one we already had common denominators. So now let's look at number 2. Number 2, it looks like we almost have common denominators. At least they're all factored for us. So I see this in both of them. Okay, so that'll be something. I see 2x plus 1 in only that left guy. And then I see the 2x or 2y minus 3 in the right hand denominator. So the good thing is we didn't have to factor. They already came factored for us. Bad news is that we don't have a common denominator yet. So what I usually say is, what is this denominator missing that the other denominator has? So looking at this first one here, okay, this one has 2y plus 1 and y minus 7. The other one already has a y minus 7, but it also has a 2y minus 3. So you are going to multiply both the top and the bottom by 2y minus 3. So what it looks like for that first one is y times 2y minus 3 all over 2y minus 3 times 2y plus 1 times y minus 7. Now, for the other denominator, I have the 2y minus 3. That's good. I have the y minus 7. Yay. But the one that I'm missing that the first one has is 2y plus 1. So we have to multiply both the top and the bottom by 2y plus 1. In order to get all of the same factors. So it doesn't matter what order they're in, just as long as you have all of the same factors on the bottom. Okay, so look at this. We have 2y, oh, crudsicles. Why did it do that? I don't know. I selected that. There we go. We have 2y minus 3, 2y minus 3. Yay. We have 2y plus 1, 2y plus 1. Woohoo. And then we have y minus 7, y minus 7. So look at all of them are highlighted and we have all of them in both of the denominators. So now they are common denominators, which means it's all just going to be for the one denominator. And we can now condense the numerator. Okay, so the numerator, if we distributed that, we'd get 2y squared minus 3y. Bring over the plus sign. And we're multiplying by 2y squared. So plus 4y to the third plus 2y squared. From there, we can combine our like terms. So we get 4y to the third plus 4y squared minus 3y. All over 2y minus 3, y minus 7, 2y plus 1. So this to me right now looks like a hot mess express because there's just a lot still there, especially because we condensed the top, but now we should probably try to factor the top. So factoring out the top, we have a y that can be factored out. Then we get 4y squared plus 4y minus 3 all over this big denominator. Factoring out the top, okay, there's a couple ways that we can do this, but essentially what's going to happen, well, what I say to kind of look at is look at your denominators. Okay, they have a 2y minus 3 and a 2y plus 1 and a y minus 7. Okay, the y minus 7 isn't going to cancel out because it's not multiplying to 7 or any multiple of 7 up here. So looking at these, what I would try to do in order to factor out the 4y squared plus 4y minus 3 is I would try it with like 2y minus 3. So 2y times 2y gives you 4y squared. A negative 3, it would have to be times a positive 1, would give you that negative 3. But does it add to give you a positive 4y? If we were to like FOIL this. So this is 2y, negative 6y. So that would actually give you a negative 4y. So this is not the factored form of it. Okay, which actually means that this is like the simplest version of it. You could have either one of these be the simplest version of it. So it looks like a mess. It's always good to try to factor it out to see if you can cancel out any of the common factors, but in this case, we can't. Okay, we're just gonna do these next two and then I'll give you guys a break. And then we'll get into these ones aren't as bad. Adding and subtracting is honestly the hardest for these ones. And then homework is like to finish up any of the ones that we didn't do. Okay, so let's finish up these number 3 and 4, and then we'll take a short break. Okay, so what we want to do is we want to look at only the denominators to see if they can factor at all. So that first one, I'm just going to keep the 5x minus 1 like that. That first one can factor out into x minus 2 times x minus 1. That right-hand side, there's only 2 terms, but it doesn't have an exponent. So we would try to GCF, which would mean pulling out a 2. So now let's look at the ones that they have in common and then the ones that they're missing. So the x minus 2, they both have. But the left-hand side has an x minus 1. The right-hand side does not. So you would want to multiply both the top and the bottom by x minus 1. So now that they both have an x minus 1 in the denominator. Now on the right-hand side, the 2, that has a 2. This left-hand side one does not. So we would multiply both that top and bottom by 2. So now we have 2, 2, x minus 2, x minus 2, x minus 1, x minus 1. Now they have common denominators. They have all their factors are the same. Okay, so now what you do is you can condense into one denominator since they're exactly alike and condense the numerators. So these ones are just straight up distributing plus x minus 3. And from there, you're going to combine like terms on the top. So we would just get 13x minus 5 all over 2 times x minus 2 times x minus 1. You can't factor any more on the top, so that is the simplest version of it. So now for this last one, what I want you guys to do is I want you to factor the denominators. And I want you guys to see if you can come up with what the common denominator will be. And you could private message me what the common denominator would be. And if anybody needs any help, you can message me or you can ask out loud. That's totally fine either way, whichever way you're comfortable with.
I have a question. So I have the like 4 over x minus 4 and then x plus 4
Yes.
plus 3 over x plus 4 and then x plus 4 again.
Yes.
So what I just put, I don't know where to go from there actually.
Okay. So, yeah, this is a good question. So look at, if we were highlighting the ones that they have in common, they really only have an x plus 4 in common. Only one of those. So what is the left one missing that the right one has?
Another x plus 4.
Yep.
Okay.
Does that make more sense?
Yeah, I was gonna put that, but I wasn't sure if I.
Right.
Right.
Yeah, so this one's a little different because they have the same fact, like there's two of the same factor in one, but you have to account for, okay, this one has it, so does this, but this one has another one, so this one has to have another one. They should be exactly.
Okay.
Yep, good question. So while you guys are working through this, I'll just kind of fill in and you can look at it if you want, or if you're still plugging away, do that. If you're stuck, I just kind of want to give you a step to show you. Okay, so once you get the common denominator, which they should both have two of the x plus 4 factors, okay, because there's 2 on the right side, meaning there's got to be 2 on the left side. And then you would also have an x minus 4. So the left side was missing an x plus 4. So you would distribute the 4 to the x plus 4 on the top. And then the right-hand side was missing an x minus 4. So you distribute the 3 to the x minus 4 on the top. And condensing that, you combine your like terms. So 4x and 3x gives you 7x. 16 minus 12 gives you 4. There's nothing we can factor out of that. So it would just be 7x plus 4 all over x plus 4 times x plus 4 times x minus 4. Okay. So let's take, we'll come back at 10. Okay, so about 4 minutes. Just get up, make sure you get up, move around. If you want to get something to eat or something to drink or use the restroom, do that now. And we'll come back at 10. Okay, whenever I get like a thumbs up or just knowing that everybody's here, we could start back up again. I see Abby, she's there. She's got her Bills gear on. Love it.
I have a question on my take-home quiz that we have to do this weekend. It's like I've been like staring at it for I don't even know how long.
Yeah, yeah,
So
yeah. Do you want to do it at the end of this when everybody gets off and then I could stop recording and then I can
Yeah.
help with it?
Yeah, that'd work.
Okay, perfect. Sounds good. Is it dealing with factoring or are you, oh no, you're doing synthetic and long division, right? You said?
Yeah, but we all did like really bad on our other tests, so she wants to like give us a chance to, I don't know, redeem ourselves. So we have like this quiz and it's just like this one question. I've never seen it before and I don't know how to do it.
Okay, no problem. I'll throw it at the end. Not a problem.
Also, I was also gonna ask you, I can get help with my factoring homework too.
Yeah, sure. Yeah. You guys can
Okay.
just stay on at the end and I can help. Yeah,
Okay, thanks so
Thank
much.
you.
yeah, no problem. Okay, so so and basically any of the ones that for this that we didn't do together. So I'll kind of highlight these ones right now that I would have to have you guys do on your own. I don't know if you guys want to circle them or whatever. Oh, crudsicles. Why did it do that? I wanted it a highlighter. Highlight. Okay, there we go. So like numbers 3 and 4 on page 2, you'll have to do for homework. A and B here, because those are, you're gonna want to, factor out the tops and then cancel out anything that you can that's in common. I'm also gonna have you guys do this for homework. Okay, so far that's what I have you guys doing for homework. We'll have more at the end, but just as a heads up. Okay. So we are on page, oh, crudsicles, why does it do this to me? There we go. Okay, we are on page 4 and it says simplify by multiplying first. So with these, when you have like a monomial divided by a monomial and same thing, and then you're multiplying them, honestly, the easiest way is just to multiply the numerators together, multiply the denominators together, and then kind of cancel out anything that you have in common. So here's what I mean. So on the top, if we're multiplying 6x squared y cubed times 10x cubed y to the 4th, if we were doing it with the rules that we talked about earlier, we would do 6 times 10, x squared times x cubed, y to the 3rd times y to the 4th. Okay, so on the top, we'd get 60 x to the 5th, y to the 7th. Bottom, you do the same thing, except this time on the right-hand side, it only has a y, it doesn't have an x. So you just multiply the 2 times the 18 to give you 36. You bring the x squared along for the ride because there's no other x's to be multiplied by. And then y squared times y squared is y to the 4th. Now that we just have one term on the top, one term on the bottom, now you can simplify. So 60 divided over 36, let's see, I think, 12 can go into both of those? Yeah, 12 can go into both of those. So we get a 5, and this is where you like go like this. You simplify it that way. So we get a 5 over 3, because you divide both of those by 12. X to the 5th divided by x squared is x to the 3rd. Keep that on top because that's where the bigger one was. And then y to the 7th divided by y to the 4th is y to the 3rd. And again, that stays on top because the bigger exponent was on the top. Okay, so that would be the simplest expression. these next two, it says simplify by factoring first, then multiply. So we did one example like that. I'm going to do one more with you and then ooh, crud. I don't know why it keeps doing that. A is going to be for homework. So we're going to do B together. And C is going to be for homework. Okay, so you kind of have to bop around with some of the homework problems, but basically you're just filling in the things that weren't filled in with us. So we're looking at B here. And anytime you have a fraction multiplied by an expression, I always put the expression over 1, just so that you know what goes on the top and what goes on the bottom. Okay, so looking at this top left one, I know I can factor out a 2 and get x squared minus 1. The bottom left, you can double bubble. To give you, it has to add to -6 and multiply to -7. So x minus 7 times x plus 1 times the 1's going to be on the bottom. Then we can double bubble that top right. So it adds to -10 and multiplies to +21. So when it multiplies to a positive number, it means both the signs have to be the same. Since it adds to a negative number, both of those signs are going to be negative. So now you just got to think, okay, well, what numbers multiply to 21 and add to -10? So those two numbers would end up being 7 and 3. 21 doesn't have that many factors either. Looking at this, the only issue I'm seeing is that there's still a squared right up here. Ooh, I don't like how that just highlighted that like that. Okay, let me pick a different color because it basically just like took it out. Let's see. That's a little better. Okay, so that x squared minus 1 is still an issue because it's not completely factored. So we would still have to double bubble that. Oop. And that should be x plus 1, x minus 1 all over x minus 7 plus 1. And then copy everything else down. Now, since we're multiplying, we're going through and seeing if there's anything on the top that can cancel with anything on the bottom. So 2, there's no other 2 on the bottom, can't cancel it. X plus 1 on the top, there is an x plus 1 on the bottom, so we can cancel those. X minus 1 on the top, there's none on the bottom. X minus 7 on the top, and then x minus 7 on the bottom. And then x minus 3, there's only a 1's left on the bottom. So overall, we just multiply everything that we have left over on the top, and the bottom is just 1. So you're just left with 2 parentheses x minus 1 parentheses x minus 3. And that's as simplified as you can get that. Okay. So A and C are very similar to that. You'll want to try that. Sorry, I'm just looking to see which ones I would like to do. Okay, so for division, it's not much different from multiplication because we are going to be using multiplication, but what you have to do first is you have to keep the first one, change it to multiplication, and flip the second one. So it's called keep, change, flip. So looking at letter A, we'll do this one first. So if you're dividing by any sort of fraction, you keep that first fraction, change the division sign to multiplication, and flip the second fraction. So with these ones, we saw that when we had the monomials, we just multiply on the top, multiply on the bottom, and then condense. So I want you guys to try that for me, please. So just try condense the top, condense the bottom, and then simplify. So tell me what you get in simplest fraction form. How are we doing?
My thing wouldn't let me do like the X
Oh,
3 on my like keyboard, so I just put cubed.
perfect. Thank you. So when I multiplied on the top, I ended up with 6x squared y z squared. And on the bottom, I ended up with 6x squared y cubed z squared. So 6, so then you can like separate it like this. I know the parentheses are a little funky this time around because I did them too close together. Okay, but 6 divided by 6 is 1, they cancel out. X squared divided by x squared is 1, it cancels out. Same with this one. So you are left with y over y cubed. And that simplifies into, you could eat, so technically what's the exponent for y?
-2.
Oh, okay, yeah. So the final one would be -2 because this one has like an exponent of 1, right? Or you could rewrite it as 1 over y squared. So when you cancel these, and when I say that they're canceled, we're dividing them, and like 6 divided by 6 gives you 1. So when I say cancel, I don't mean that it gives you 0, it gives you 1 instead of 0. So yeah, so canceling for division is a little different than canceling like when you're combining like terms. Combining like terms, if you had 6x minus 6x, it would give you 0. They would go away. Okay, but in this case, it gives you 1. Okay. So letter B we'll do together. This one's a keep, change, flip again. Okay, and I rewrite it first and then I start factoring. So I keep this, I change this. Because this isn't a fraction, make it 1 with a 1 on the denominator. So then you can flip it easier. And then you can start factoring. So that top left one, it adds to -14 and multiplies to +48. So when it multiplies to a positive, it means that they're both the same sign. And the sign that they are is whatever the sign is in the middle. So if it's adding to a -14, they're both going to be negative. And for this, we get 6 and 8. The bottom, there's only 2 terms, which you can either do GCF or difference of 2 squares. Since they both have an x in common, you could factor out an x and get x minus 6. And then the bottom right is another GCF. And it's 3 times x minus 8. So from here, x minus 6 is in the top, it's in the bottom. X minus 8 is in the top, it's in the bottom. So look at, we're left with a 1 on the top and a 3x on the bottom. Number 6, I am going to have you guys do for homework. I just do want to write the first step for you guys because I know that looks a little tricky. So it's combined operations with division and multiplication. So remember, for division, you keep, change, and flip the one right after the division sign. So if we were to do that right off the bat, it would look like this. Okay. So I'm going to give you that first step, but I do want you guys to complete that as well for Tuesday. Okay, the last part. So actually we're doing really good on timing today, which is what I always get nervous about, is that we don't finish it. So yay, we're finishing it. So for rational equations, meaning we have fractions on either or both sides of the equation, it is essential to first find the least common denominator. Once you have that, you can condense each side of the equation, cancel out the denominators since they will be the same, and then solve the equation involving only the numerators. Make sure to check for extraneous solutions. So extraneous means solutions that if you were to plug them in, they wouldn't check out because the denominator would be 0. So denominator cannot equal 0. Okay. So when you check for the extraneous solutions, mostly you could just plug it into the denominator to see if it gives you 0. If it doesn't, then you're fine. Okay. So what we're going to be doing is we're mainly going to be focusing on the denominators. As you can tell, for a lot of these, that's what the big thing is, especially for adding and subtracting. So we're going to be doing, I want to say I wanted to do the odd ones with you guys. Yeah, we're going to be doing mostly the odds till whenever we stop. Okay, and then you guys will have mostly the evens. So looking at number 1, my denominators that I see are m, 4m, and 2m. Always look at the bigger number. Okay, so the 4. I can multiply 2 to get 4, so that should work out. So 4 is definitely part of the least common denominator. And then looking at them separately, you always take the highest power of the variable. So the highest power is just m. So we should be able, if we wanted to, multiply all of these to get us 4m. Okay, so has anybody done this yet? Like in class at all? Has anybody done anything like this? No? Okay, so what we're gonna do, it's gonna be very similar to when we were adding and subtracting above. So we wanna get common denominators, and they should all have the denominator of 4m. So like for this one, I'm gonna multiply by 4, multiply by 4. I get 8 over 4m. This one already has 4m, so I'm okay. Then this last one, you can multiply it by 2 on the top and bottom. And look at that. So they all have the same denominator. And when that happens, the denominator basically just goes away. Like you ignore it for now. And you solve it like you would a normal equation. So we have 8 equals m plus 2 plus 2. So 8 equals m plus 4. Subtract 4 from both sides and you get 4 equals m. If you were to plug 4 in for m on the denominators, none of them would equal 0. So this is a good final answer. Okay, let's jump to number 3. So there's 5, 5, and then technically a coefficient of 1. So 5 would be fine to multiply to. They all have a variable of p, so we can just say 5p is the least common denominator. So the only one that doesn't have a 5p on the bottom is the one on the right side of the equal sign. So you would just multiply the top and bottom by 5. Everything else you can keep the same. And since they all have the same denominator, those can just cancel out so that you have a linear equation. So p minus 3 plus 1 equals 5 is your linear equation, which we would end up with p minus 2 equals 5 or p equals 7. Plugging that into the denominator doesn't give a 0 on the denominator, so this is fine. Okay, sorry, I'm just looking ahead real quick. Okay, actually, we're going to do number 6 instead of number 5. Okay, so number 6, the least common denominator. The highest coefficient is 6, which I can multiply 2 by something to get 6. And then this one is just a 1, so you can multiply 1 by anything. So 6 looks fine. And then they all have p squared. So p squared is part of the common denominator.
Mom,
oh.
Daddy needs some scissors.
Sorry, you needed scissors. Okay, so, oh, crudsicles, stop doing that. Okay, so the least common denominator is 6p squared. So to get this to be 6p squared, you would multiply it by 3, multiply that by 3. Multiply this by 6, multiply this by 6. Then that last one's fine. It already has 6p squared. So the top up here ends up being 3p plus 6 all over 6p squared. That next part is 6p plus 36 all over 6p squared plus 1 over 6p squared. They all have 6p squared, so those can just go away. Since they're all in common, you could just kind of get rid of those. And then you can just focus on the numerator. So we get 3p plus 6 equals 6p plus 37. I would subtract 3p from each side to give me 6 equals 3p plus 37. And then you can subtract 37 to get negative 31 equals 3p. So then p would end up being negative 31 over 3. Okay. So these ones, these next few are all kind of similar to that. Just make sure if you don't see a denominator, you put one. Okay. And then going into something like number 12 here, what you'd want to do is you'd want to factor it. So we're bouncing to number 12 just for time's sake. So number 12, if you were to factor this, you'd get a minus 5 times a minus 3. Okay, and that's what you would get for both of these. So that last one is the only one that's missing anything, and it's missing a minus 5. So we get 5 over a minus 5 times a minus 3, 1 over a minus 5 times a minus 3, plus a minus 5 all over a minus 5 times a minus 3. The denominators are all the same now. So we could just say it's 5 equals 1 plus a minus 5. Or 5 equals a minus 4. And if you added 4 to both sides, you get 9 equals a. If you were to plug that in to all the denominators, you would not get 0. So this is an acceptable answer. Okay, so let's leave. I'm just going to have you guys fill in the ones up to number 12. Okay, so don't worry about that last page. Those ones are a little bit tougher anyway. You don't usually see these tougher ones on the SAT. So just do, I'll highlight all the ones that you're going to want to do. So you have 11, 9, 10, 7, 8, 4, 5. Okay, and 2. So 2, 4, 5, 7, 8, 9, 10, 11 for the rational equations. And then on the other page, you just want to finish A and C on the top. On page 4, it's A, and then all the ones on the top from example 1 and 2. And then I think just that 3 and 4. So like I said, it's kind of bopping around a little bit, but you've got it. Let me just plug this in before it dies. Okay, so that's pretty much all dealing with rational expressions. The only thing we didn't get into was the synthetic or long division yet, which those, Usually it's not gonna be synthetic, it's usually gonna be long division. So we'll focus primarily on long division. But yeah, that's something that you guys can definitely look forward to. So, I am actually going to stop recording. Let me see how I do that.